It is a very beautiful lecture, and definitely it is the first time ever lecture in my life on double pendulum and introduction of chaotic motion. As a first time student from APC College, I'm very glad to tell that it is very interesting and very wonderful experience in my life, and definitely I'm presenting this slide only for you. So let's start. So I've made this presentation, and it's just animation and I can show you. So I hope so it is not working for something, but it is just a dynamical of the dynamical picture of a double pendulum. So for the next slide, we can ask anyone why physics is very important for learning. So definitely we know physics is very important to understand the how the nature works, right, biologically and mathematically. But not only understanding the concept of nature, but also why physics, because of our self realizations, right, our increase our concentration, increase our focus, different type, and that can use to enrich our knowledge, our logical power, so we can practice some different mathematics and physics randomly. So what is the next is actually there is a beautiful course from the Soringer, that is the total number of minds in the universe is one. In fact, consciousness is a singularity fizzing within all beings. Arvind Sorinder's realizations after studying the physics and after working different type of research, his realizations. So it's very interesting. But there is a very important and wonderful quotes from Gita that I like more and more. So what is this? That is actually Srimad Bhagavad Gita. Maya tadamidang sarvang जगत व्यक्त मुट्टीन मस्तानि सर्वभूतानि न चाहं tishavastita. So the meaning of this stranger, that is this entire cosmic manifestation is pervaded by me in my unmanifest form. All living beings dwell in me, but I do not dwell in them. So it is Krishna's realizations, God's stranger for Arjuna, right? So what is the next? The next, what is our conclusion? The conclusion is actually that why physics is for definitely self-realizations, emotional balancing like simple pendulum, inner engineering like machine learning, AI, increasing concentration like convex lens, focus like laser, problem solving skill in life in by like Python, K of absolute happiness like double pendulum, fearless mind like rocket motion, spontaneous creativity like matplotlib, and so on. The power of our subconscious mind and realizing the actual truth of human life. So if you ask what is feel, right, what is feel to ordinary person, I hope so what is that, what is like that, right? So he will definitely tell you like that, it is like that. So it is very interesting a picture, and here farmer is there on the field, and definitely the ordinary person feel like this, right? But what is the actual field? If you imagine the field, if you imagine the empty space, there are no molecule, there are no interaction, so what will be the actually picture, right? The picture will like that. And definitely it is just a simulation, and simulation is very interesting simulation. I hope there is a problem. So it's just a beautiful simulation, and by the professor direct Lane Weinberg at the University of aldehyde. So it is very interesting. And if for the next slide, if we observe our universe from the past, and what actually it is like that the Big Bang is there, and there are different type of force in our nature, like right, four types: strong nuclear force, electromagnetic force, weak nuclear force, and gravity. And there are different type of time scale and their introduction, right? So you can see here the actual time range and temperature range, that the time of after Big Bang, right, into the power minus 43 second, right? And definitely at the time the temperature is like that, into the over 32 Kelvin. So at this time the gravity actually introduced, right? So it is very, and for like that the different cases, strong nuclear force, electromagnetic force, weak nuclear force arrived. We all know this type of information and knowledge, right? It's very interesting. And if we ask a ordinary person, you know the definition of chaos, and definitely I hope his mind thoughts is like that, right? It's very interesting picture. You can see that is chaos. Yes, it is his office, and it is full of chaotic, and it is your beautiful face after hearing, after listening this type of answer, right? So it's okay. So if and definitely for is the, and if you want to study the chaotic motion, definitely we know we should study, when we need study the study double pendulum, right? So what is the basic difference between the simple pendulum and the double pendulum, right? So the simple pendulum, the bob just has one string showing predictable regular motion, great for clocks. Double pendulum adds the second pendulum fast bob, creating the complex and unpredictable chaotic motion, and sensitive dependence of initial condition even with the teeny nudge, making its classical physics demo for the chaos theory. The key difference lies the phase space. So simple pendulum theta 1 and theta 2, 2 theta are the phase space, and the double pendulum theta 1 theta 2, theta 1 dot means the momentum, and theta 2 dot and momentum is the phase space. So it is simple pendulum structure is very simple. The motion, and the predictability is highly predictable. Its swing path is easy to trace. And physics is demonstrated basic periodic motion can measure gravity, and for the interesting case on the double pendulum, the structure simple pendulum with another simple pendulum attached to its bob. Motion is very complex, erratic, and simply random motion, especially at larger swings, and predictably and highly extremely sensitive to initial condition, deterministic chaos. Minuscule scale studying portion leads to the drastically different result over time. And physics, a classical demonstration of chaos theory, nonlinear dynamics, and the energy transfer. Complexity simple of elementary, double is very complex, and maths simpler for simple pendulum, and complex for the complex pendulum. And definitely we see the double pendulum, and there are a Lagrangian equation. Lagrangian means the total kinetic energy minus potential energy, and definitely we can find out the equation by Lagrangian method. The equation of motion of the double pendulum is like that, and you can see in the slide here, and this just expression. So it's okay. So definitely I can show you the actual equation of motion of the double pendulum, and it is very interesting. And you can see here that there is two bob, and the first bob makes theta 1 angle with the axis y1. Y1 is definitely the negative axis, and the mass m2, and it is makes angle from theta 2 from the angle and from angle theta 2, right? They're differently the different angle, right? You can definitely imagine this type of picture. Here x1 is a position of the m1, and x2 is a position of m2, y1 for m1 and y2 for m2. And definitely by using, and for is the length, L1 is the length of the mass 1 bob, and L2 is the length of the mass 2 bob, and we can write the equation of motion for x1 means the L1 sine theta 1, right? x2 means L1 sine theta 1 plus L2 sine theta 2, right? And y1 means minus L1 cos theta 1, and y2 means minus L1 cos theta 1 minus L2 cos theta 2. Minus is for the negative coordinate. And what is the potential energy? The potential energy is actually m1g y1 plus m2g y2. You can see here of this picture, and you can definitely write this type of potential energy, and we just put the value of y1 and y2 into the equation of potential, and equation 5 is the ultimate equation for potential energy. What is the kinetic energy? Half mv1 square plus half m2v2 square. So v1 square means x1 dot square plus y1 dot square, because they are the two coordinates. That's very important to define the velocity, right? So and we can definitely find out the x1, because we know the x1 is here, so x1 dot is actually it is x1 by dt plus so dx1 by dt and dy1 by dt, and x2 is here and y2 is here. So x1 dot is it's like that, and x2 dot is like that, and y1 dot is like that, and y2 dot is like that. You can definitely from the basic calculus, you can definitely write this type of equation. So what is the total energy? And we will put this type of for quantity x1 dot, x2 dot, y1 dot, and y2 dot into the kinetic energy part. So it's okay, and it is the total energy term, and you can see here the different term after putting this type of the different variable, and it is a final portion of the total kinetic energy, that is the equation 6, and it is a potential energy, right? So what is the actual Lagrangian? Lagrangian means the L equal to kinetic energy minus potential energy. So Lagrangian means definitely we will put kinetic energy and potential energy, the difference definitely in this equation, and it is very important, right? So definitely, what is the Euler Lagrangian equation? The Euler Lagrangian equation is d dt dl theta 1 dot minus dl d theta 1 equal to 0. Here the theta 1 and theta 2 dot, theta 1, it is the generalized coordinate, right? If theta 1 is here, theta 1 dot is the momentum, right? It is very important. The angular velocity, the angular velocity is very important. And definitely in the right side of the slide, dl by d theta 1, so we can definitely differentiate the dl with respect to theta 1. So we will find this type of equation, theta and dl by d theta 1 dot, it is like the equation, and definitely we put it our actual equation ddt and dl d theta 1 dot, and this type of equation, and we will put all this equation in the Euler Lagrangian equations, and we will get this type of equation of 7, and it is one for the second order ODE equation, and it is very important. And Euler Lagrangian equation for theta 2 is it's like that, it's similar to the upper portion, and we will and we can find this type of equation of the second equations. So what is the Lagrangian? The Lagrangian is like that, the total Lagrangian equation is like that. So yes, it is like that. So we can find this type of equation by using the Euler equation here, and just by some calculation from the Kramers rule, we will find what is the find is actually the theta 1 double dot and theta 2 double dot, and by using the Kramers rule. And if you know the Kramers rule, so you can definitely you can calculate this type of equation, and you can understand this equation. I can show you this type of, it is just simple metric formation from the equation, and it's a determinant. Kramers rule is here, and numerator is here, so Kramers rule is here. So it's just the equation, it's just the equation of the double pendulum. It is a 4 equation, that is number 1 equation, number 2 equation, a b c d is the 4 equation of the double pendulum, right? And it is very interesting, it is very interesting. So thank you for watching this type of mathematical equation, and what is our next part, right? And definitely viewers, and I can show you the wonderful Python code for the double pendulum. So just see. So it is the different curves, there is a trajectory of the double pendulum, and definitely it is the angular displacement, it is the angular velocity, and it is a phase plot. So definitely you can see here the trajectory of the pendulum is very chaotic for depending on its initial condition, and angular momentum, angular displacement is definitely is too much chaotic, and you can see it's varying with time theoretically, and the separation you can see here, and if it is the angular velocity, and there is a two angular velocity there, omega 1 and omega 2, and definitely you you have seen here, and it is a very interesting animation from my side. It is the double pendulum, and you can just see it is the chaotic behavior of the double pendulum. It is very interesting, right? It is very interesting. So just thank you for watching, and thank you for your attention. Thank you so much. Thank you. And it is a Python code. It is a four different curves. It is a phase plot is there, theta 1 and theta 2, and it is a code, and definitely you can run it in the your several it is definitely the Google Colab here, and something lag is here. So just a beautiful just a beautiful plot. So thank you so much guys for your attention. Thank you. So I can show you the code, and it is the code, and you can just pause it and try to write this type of codes in your hand and just stimulate it. It is very interesting. It's very interesting. Thank you so much